This is a large hydraulic log splitter fully built here in the workshop. First, we're going to take care of the power system for the log splitter. This requires a gasoline engine in the 5 to 7 horsepower range, paired with a GR2 hydraulic pump rated at 6 liters. Now, we need to connect the pump to the engine. I'll try to keep the design simple, but strong and reliable. Here, I'm making the mounting plate for the hydraulic pump. Now I'm bolting the mounting plate I made directly to the pump. Now I'm mounting the first part of the flexible coupling onto the pump shaft. I also made a mounting plate for the engine. Now I'm installing the second half of the flexible coupling onto the engine shaft. Now I'm connecting both steel plates with a tube. I'm keeping them mounted to the engine so I can be sure the shafts stay perfectly aligned. First, I'll tack weld everything in place. Then, I'll take the whole assembly apart and finish it with a full solid weld. The main system that drives the hydraulic oil is now complete. So next, we'll move on to building the hydraulic oil tank. This plasma cutting track was also fully built here in the workshop. First, I'm cutting all the steel parts needed for the oil tank. In my case, the tank will be quite large because the hydraulic power unit I'm building will be able to run not only the log splitter, but also other hydraulic machines. I'm joining all the cut steel plates together with short tack welds first, and once everything is aligned, I fully weld all the seams to make the tank completely sealed. The tank is now fully welded, but the top is still open. At this stage, I'm welding 4mm steel angles into the side walls. They will act as reinforcement and will also allow me to drill and tap threaded holes, because the sheet metal used for the tank is too thin to hold the proper thread. In this spot, I'm drilling a hole where the oil drain fitting will be welded in. The hydraulic power unit will be mobile, so now I'm welding on the axle for the wheels. Next, I'm working on the top plate of the tank. Here, I'll fabricate the mounts for the engine and pump assembly, and I'll also drill the holes for the oil filler and the oil filter. The oil level gauge I'm mounting here also serves an important role because it measures the oil temperature as well. The top plate I'm bolting on now also has a tall mount welded to it for the hydraulic valve. When connecting the hydraulic hoses, it's very important to know which side of the pump is the suction side and which is the pressure side. On the pump I'm using, these markings are clearly visible, but not every pump has them. The return line from the hydraulic valve is connected to the oil filter, but it's important to remember that there are different types of filters. Some are designed for the return line, while others are meant to be installed on the suction side before the pump. Not every filter can be used in both situations. I prepared the hydraulic cylinder for testing to make sure everything is working correctly. Later on, I'll replace these threaded fittings on the valve with quick couplers. I'm using a steel I-beam that I bought as scrap. I cut it to a length of about 10 to 15 centimeters more than the hydraulic cylinder when it's fully extended, so it's just the right size for this build. To this I-beam, I need to weld a steel plate that's 120 millimeters wide and 8 millimeters thick. This plate will act as a guide for the mechanism that pushes the wood toward the blade. In the holes I'm drilling, I'll add welds that tie the plate directly to the I-beam. This way I can be sure the steel plate is firmly and securely attached. base of the log splitter along with the guide is now finished. So now I can move on to mounting the hydraulic cylinder. The hydraulic cylinder is very powerful, so its mounts need to be strong as well. This is important to make sure the log splitter operates safely. The mounting bracket is ready and it looks solid. Now we can move on to the plate that will push the wood toward the blade. This mechanism needs to slide along the guide, so under the main steel plate, I'll mount a narrow flat bar that has the same thickness as the guide on the I-beam. Then, underneath that, I'll add a wider flat bar that locks the whole assembly onto the guide. This way the pushing plate stays aligned and moves smoothly. All of these parts will be bolted together, but first I'll tack weld them with a few short welds. This lets me drill all the holes at once. After the drilling is done, I'll remove those temporary welds. Once all the holes are drilled in every part, I need to tap the holes on the lower, wider flat bars for an M8 thread. In the other steel pieces, I'll enlarge the holes so the M8 bolts can pass through and screw in smoothly. As you can see, everything slides smoothly along the guide without any noticeable play. This part doesn't need extreme precision, but it's still important to keep the clearance low. During operation, this sliding block will be under a lot of force, so it has to move freely, but without wobbling. This steel plate is the part that will push the wood toward the blade. I'm also going to attach a wide bracket for the hydraulic cylinder to it, which will make the whole pushing mechanism stronger and more rigid. Fully welding everything always makes me a bit nervous because with so many pieces joined together, it's easy for the metal to warp. Even thick steel plates can deform after heavy welding. To do a quick test, I powered the hydraulic cylinder using compressed air. Now I'm building the parts that will allow the blade to move up and down. When this blade is lowered all the way down, it will be set up to split the wood into two pieces. But when it's raised, it will be positioned to divide the log into four. These two side blades will be responsible for splitting the logs into four pieces. Now we can move on to the splitting blade, the one that will break the logs apart. This blade will be moved by a small hydraulic cylinder, which gives me the option to split the wood into two pieces or into four. All of these reinforcing pieces might look like overkill, but this part of the splitter will be under extremely high forces. The hydraulic cylinder alone can push with up to 14 tons of pressure, so I prefer to add more steel and know that everything will stay safe during operation. Now I'm drilling a slotted hole in the splitting blade. This hole will be used to connect the lifting mechanism. I don't have a machine that can cut such a large slot in one go, so I'm drilling 3 holes next to each other and then shaping them with a file. These welded flat bars will act as the lifting mechanism for the blade. The shorter arm will connect to the hydraulic cylinder, and the longer one will connect to the blade itself. This setup gives me a lot of height adjustment while using only a small cylinder. lifting lever for the blade is now finished, so next, I need to install the small hydraulic cylinder that will control the adjustment. As you can see, after powering the hydraulic cylinder with compressed air, everything works correctly. So now we can move on to the next stage of the build, which is making the axle with the wheels and the frame for the entire log splitter. This log splitter will have a hydraulic lift that raises the logs from the ground and places them onto the machine. That's why I need to build a wide axle for the wheels, so the splitter stays stable and doesn't tip over when lifting heavy logs. The whole machine will be quite heavy, so the wheels need to be strong enough to handle its weight. Here I'm installing the trailer hitch connection and the foldable support wheel, which will make it easy to move and position the log splitter. Here I'm installing a side guard. When the logs roll down from the lift, this guard will keep them on the splitter and prevent them from falling off the other side. Now we can move on to the log lift. The lift will be quite long, so it's important to make it foldable for transport. I'm building mine from square tubing simply because I didn't have any sheet metal available. But if you're making one yourself, I recommend using a square tube frame and covering it with steel plates. That makes it much easier to slide the logs off the lift while you're working. The log lift is now finished, and as you can see, it also folds for transport. Now we just need to install the hydraulic cylinder. I'm making the cylinder mounts a bit longer so they wrap around several of the square tubes. This will help prevent the lift structure from bending when it raises heavy logs. Now I'm welding on the brackets for the hydraulic control valves. This hydraulic valve is made for log splitters. It has a fast extend mode with less force and a slow mode with full power. The return position has a detent, so you don't need to hold the lever. It snaps back to neutral when the cylinder retracts. The second hydraulic valve is a two-spool unit. It will be used to control the blade extension and the log lift. I'm connecting all the hydraulic hoses according to the markings on the valves. Even though there are many connections, and it looks complicated, these markings make the whole job much easier. These two hydraulic hoses with quick couplers will be connected to the hydraulic power unit. The log splitter is basically finished, but it still needs a few extra parts. One of them is a table that will catch the wood right after it's split so it doesn't fall straight to the ground. This log lift makes the work much faster. I don't have to bend down for every piece of wood. I can load several logs onto the lift, raise it, and then all the wood is right in front of me and easy to reach. This wood splitter is extremely powerful. Thin or thick logs, wet or dry, this machine handles them all without any problem. Thank you for watching, and see you in the next project.